Here we have 3 problems. We need to prove each of them. Now, all the 3 problems require one property. That is, we have logarithm of, let's say, 2 numbers, a and b. And generally, when the base is not mentioned, it's going to be 10. Then this is equivalent to log of a plus log of b. Each of them has a base of 10. Now this is the property that we will use to prove each of the 3 problems. So let's begin with problem number 1. The first problem, we have log of 12. All we have to do is find the factors of 12. We know that 3 times 4 is 12. So here, if we consider 3 to be a and 4 to be b, then this will be equals to log of 3 plus log of 4. So we have proved the first one. Let's go to the second one. So in the second problem, we have log of 50 with a base of 10. The log of 50 can be also written as, we have 5 times 10 is 50 and 10 is 5 times 2. So this is going to be the factors of 50. Now, if we apply the property, then this will be log of 5 plus log of 5 plus log of 2. So it doesn't matter if we have only 2 numbers that are in product. It could be more than 2, but the property will remain the same. Now, the first term and the second term is exactly the same. So this will be 2 times log of 5 plus log of 2. This proves the second one as well. Now let's move on to the third one. Third one is a very interesting problem. Although it looks like if we have log of a plus b, that is equals to log of a plus b. It looks like this, but actually this is not the case. Log of a plus b is never equals to log of a plus b. We cannot distribute log with a plus b. The thing is, what is happening here is, first we need to add the 3 numbers. So 1 plus 2 is 3, 3 plus 3 is 6. Right. It means the same thing. Now, what's 6? What are the factors of 6? So that will be 1 times 2, 2 times 3. Now we can apply the property. Then this will become log of 1 plus log of 2 plus log of 3. So this is how we have proved that log of 1 plus 2 plus 3 is equals to log of 1 plus log of 2 plus log of 3. Never make the mistake that log of a plus b is equals to log of a plus log of b. This is not true. In problem number 2, we need to express each of the problems as a single number. Now each of the problems are very unique. They are going to use several properties of logarithm. So we'll try to understand the properties with the help of this problem. So let's start with the first problem. Our first problem is given. We have log of 2 plus 1. So here the question is to combine them to form a single number. Here we cannot add 1 to log of 2 straight away, because this also has to be in the form of logarithm. Now, as I mentioned, this logarithm has a base of 10. Now, if we have log of a to the base of a, this value as per definition is always going to be 1. So using this definition, we can say that if we have log of 10 to the base of 10, then it's also going to be equals to 1. So if we are going to use this property and rewrite our problem as log of 2. So here I have omitted using 10. It will be understood that this base is 10 plus 1. So 1 will be log of 10, because log of 10 is equivalent to 1. Then we can use the property the log of a plus log of b. This is equals to log of a times b. So log of 2 times 10, that's 20. So we have log of 20. This is going to be now the sum of log of 2 plus 1 expressed as a single number. Let's try out problem number 2. So in problem number 2, we have log of 12 minus log of 2 minus log of 3. So what we'll do, let's take the second term and the third term. Here we are going to take -1 as the common factor. So this gives us log of 2 plus log of 3. So we have log of 12 minus, so log of 2 plus log of 3. So this will become log of 2 times 3. So this is 6. Now we can combine these two logarithms. So there's a minus sign here. That means we can use the property that log of A minus log of B. So this is going to be equals to log of A over B. So if we use this property, then we'll have log of 12 divided by 6. And 12 divided by 6, so that's 2. So this value is equals to log of 2. So log of 12 minus log of 2 minus log of 3, this is equals to log of 2. Right? This is not the only way. We would have done is we could have combined the first term and the second term using this property. So we have log of 12 minus log of 2. So if we use that, then that will become log of 12 over 2 minus log of 3. So 12 over 2 means we have log of 6 minus log of 3. Then again we use the same property. We have log of 6 minus log of 3. So this becomes log of 6 over 3. Then log of 6 over 3, this is equals to log of 2, and we obtain the same result. You can also combine log of 12 and negative log of 3 first. Then whatever is the result, subtract log of 2 from it, and you will obtain the same value. You should try that out as well. Now let's go to the third problem. Problem number 3. So we have 3 times log of 2 plus 2. So we need to combine these two values. So let's begin. So here we can rewrite this as 3 times log of 2 plus 2. So we can rewrite it as 2 times 1. Right. So we'll use the property that log of 10. So that's always equals to 1. So instead of 1, we are using log of 10. Will means the same thing. Now we are going to use a property here. The property being, if we have a times log of b, then this is the same as log of b raised to the power of a. So that means we have log of 2 raised to the power of 3. We've used this property, plus log of 10 raised to the power of 2. Right. Now we have log of 2 cubed. So 2 cubed is 2 times 2 times 2. So that will be 8. Plus log of 10 squared. So that's 100. Now we can finally apply the property log of 8 times 100. So this is going to give us log of 800. So that means 3 times log of 2 plus 2. This is the same as log of 800. So let's try out number 4. So problem number 4, we have log of 2x plus 2 times log x. So what we can do, we can raise x to the power of 2. So that means we have log of x squared, means the same thing. This is the same as 2 times log of x. Now this is a and this is b. That means we can use the property, since there is a positive sign here. So we have 2x multiplied to x squared, and this is going to give us log of 2x cubed. So this is the value of log of 2x plus log of x squared expressed as a single number. Let's move on to problem number 5. So in problem number 5, we have log a squared minus log a. So we can straight away use the property of logarithm. So we have log of a squared divided by a. So this will be equals to log of a. There's also another way. So log of a we have squared, which we can rewrite it as, we can bring the 2 to the front. So we have 2 times log of a minus log of a. They are like terms. So 2 log a minus 1 times log a. So this will be equals to, so we have 1 log a, or simply log of a. Means exactly the same thing. So we have obtained the same result. Let's go to problem number 6. Then again, problem number 6, there is not a single way. There will be multiple ways of solving the same problem. So I'll be using the method. So we have half log of 9. What we'll do, we'll raise half as the power of 9. So we have log of 9 raised to the power of half. Plus we have 1/4 multiplied to log of 81. So that's the same as log of 81 raised to the power of 1/4 plus log of 6 raised to the power of 2 minus log of 12. Right. Then moving on, now what's 9? 9 is 3 squared. So we have 3 squared raised to the power of half plus log of 81. 81 is a 3 raised to the power of 4, means the same thing, whole raised to the power of 1/4 plus log of 6 squared. So that will be 36 minus log of 12, right, which will be equals to log of, so we have 3 squared whole raised to the power of half. So we know that when this is the case, so here the property being, we have a raised to the power of b whole raised to the power of c. This is equivalent to a raised to the power of b times c. So if we use this property, then 3 squared raised to the power of half, this will be 3 raised to the power of 2 times 1/2 plus log 3 raised to the power of 4 times 1/4 plus, so here we can combine the third term and the fourth term. So we can have log of 36 divided by 12. Right. So this will give us, so here the 2 and 2 gets cancelled, here 4 and 4 gets cancelled, so that's 1. So we have log of 3 plus log of 3 plus 36 divided by 12, so that's 3. So we have log of 3. So we can see these 3 terms are exactly the same term. So we have this is equals to 3 times log of 3. We can leave the answer as 3 times log of 3, or we can go ahead and we can raise 3 as the power of 3. So this becomes log of 3 cubed. So 3 cubed means we have 27. So log 27 is the final answer. The 3 log 3 can also be the final answer. We can also express log of 27 as a single number, which is the value of this particular sum of 4 logarithms. Let's move on to the next problem. Problem number 7. So let's begin. So we have half log of 9. So we will rewrite it as half log of 9 is 3 squared, means the same thing. Minus, so we'll take 3 and raise it to the power of 4. So we have log 4 cubed. Plus, similarly, we have log 2 cubed. Fine. Now what we'll do, we'll bring this 2 to the front. That means multiply with log of 3. So we have 2 over 2 times log of 3 minus log of 4 raised to the power of 3. So that is 64. Plus log of, we have 2 cubed. So 2 cubed will be 8. So here 2 and 2 goes away. And this leaves us with log of 3. Well, let's write the third term as the second term, log of 8 minus log 64. Right? So we will add the two logarithms. So that will be log of 3 times 8. So 3 times 8 is 24. So we have log of 24 minus log of 64. And finally, we can combine these two logarithms as log of 24 divided by 64. This is log of, so we can divide both the numerator and the denominator with 8. So 8 times 3 is 24 and 8 times 8 is 64. So log of 3 over 8, so this is going to be the final answer. So this is the value of half log of 9 minus 3 log of 4 plus 3 log of 2 expressed as a single number. Let's try out our final problem, problem number 8. So here we have 1 minus 1/3 of log 64. Right? So 1, this can be expressed as log of 10 because log of 10 is 1. The reason why we are rewriting 1 as log of 10, that's because we want to combine the two terms. Minus log of 64 raised to the power of 1/3. So what we're doing, we have raised 1/3 as the power of 64. So this will be equals to log of 10 minus log of, now what is 64? 64 is 4 cube. So we have 4 cube raised to the power of 1/3. We have log 10 minus log 4 raised to the power of 3 times 1/3. So 3 times 1/3 means this is simply 1. So we have log of 10 minus log of 4. So we can combine these two to get log of 10 divided by 4, or simply log of 5 over 2. So this is the value of 1 minus 1/3 of log of 64 expressed as a single number.